Hello and welcome to our panel on 3D education and why it matters. In the next 45 minutes, we'll be discussing the benefits that 3D printing offers to students, as well as how educators and companies can help contribute the resources that are necessary to incorporate 3D printing into current curriculum. My name is Sanjana Narayanan, and I'll be moderating today's panel. I'm a student ambassador for the Women in 3D Printing Next Gen initiative. Now let's meet our panelists. So Shweta, would you like to briefly introduce yourself?
Sure. Thank you for having me here, Sanjana. And thank you, Nora, and the TIP 3D Printing Conference Group for organizing this amazing conference. I think it's a great opportunity for all the females to come together and discuss, talk, share their experiences, and make great ideas. A little bit about myself. I'm the founder and CEO for a 3D printing startup in New Jersey called 3Educators. We are all about educating and empowering communities on the benefits and uses of 3D printing and how awesome it is when you try to introduce it in schools and early age, trying to change the pedagogical way of how learning is. So hands-on learning, that is the way we want to see our future of education as. So we've been doing a lot of projects in schools in New Jersey and New York. And along with that, during the pandemic, last 6 months have been really hard on everybody. So we've all had our challenges, and with that learning in mind, I actually took a step forward with all the realization that I had and founded a Women Empowerment Foundation in India, which is called the Art of Making Foundation, to empower women with hands-on learning to make anything with 3D printing and harness the power of cottage industries. So we can have, environmental friendly goods like handbags, or just reviving the old culture where we use jute and environmental friendly products. So a goal towards entrepreneurship and how 3D printing can be vital in education from an early age. That is what I feel 3D printing is all about. And it is the future, we all know that. And it's changed the way we used to think like 5 years back. My changing experience came during the pandemic, especially during March, when New York was so badly hit and hospitals ran out of supplies. And that is where we came in. 3D printing came in. So that was my eureka moment to believe that 3D printing is God, and it can change the way we think, from emergency healthcare to being accessible anywhere in the world. I think it is the future for everybody, and the youth, the sooner they adapt to it and harness its unlimited potential, I think there's a way for growth for everybody. So yeah, thank you for having me aboard.
Thank you so much, Shweta. And Mayra, would you like to give us a short introduction as well?
Hello, everybody. Thank you for having me here. I'm from Brazil. I live here, but I started using 3D printing in the US when I was doing my PhD. I'm a dentist, and I discovered the group, the Women 3D Print group, during my PhD, when I was trying to search how can I figure out my project when I was using 3D printing to produce some night guards, some splints. And I discovered the power of having a community supporting us and to learn with other people, because everybody's starting, even the olders in this area, everybody is starting now. So it is good to have the opportunity to help others. We are always learning when we help others. So I discovered how to use this 3D printing in dentistry. And I feel here in Brazil it was difficult for the students to start using 3D printing in dentistry because we don't have a lot of printers. Nowadays we have more, but at the beginning we don't have a lot of printers. And the teachers, they don't know how to use this. And even the students, they feel like that they have to be advanced to use this. And in my opinion, we have to start using at the beginning of the university, or even when she was talking about at the beginning of at the school. So when they go to the university, it is important to understand the opportunities 3D printing and other technologies give us to improve, to innovate something. So the same techniques are the last 10 years, the last 100 years, we are doing the same in dentistry. But now we have the opportunity to create new technologies or new things. And I believe the students, they know how to do it. They are really familiar with technology and they can improve with the teachers. So my goal now is to go through this education. And because of this, I founded my company that in Out 3D that helps people to go through this path and start using 3D printing in dentistry.
Thank you so much. And Joan, would you like to introduce yourself now?
Sure, thank you. And thank you for having us here and for putting together a wonderful panel. So I'm a rocket scientist by original training. One of the advantages of being a lot older than the rest of you is I've done a lot of things. So I spent 20 years at NASA's Jet Propulsion Lab doing rocket scientist stuff until I decided I want to do something else. I fell into 3D printing as a third of a Kickstarter-funded 3D printer company, where I was for several years. Unfortunately, that company didn't survive. The many companies that all came in together at the same time and the drops in price. And so one of the other people in the company and I said, nobody's doing training. Nobody's teaching people how to use 3D printers. And we started off there. And our company's called NonScriptum LLC. And if you click on my name, you can get to our website and all that good stuff. So we founded that in 2015. We've written 7 books. We're best known for Mastering 3D Printing, which is now in its 2nd edition. We started off teaching people how to use 3D printers. And then we realized that really what you need to do is to teach people why to use 3D printers. And so, we said, well, it's all fine to teach. We were sort of spread around from K-12 up through corporate people learning to do this stuff, and people really didn't know, what to do with it. So we took a step back and said, all right, now we're going to think about how do you completely change certain key industries, and started out mostly with education. So we have a couple of books of 3D printable science projects, and if you've seen a lot of science projects out there or math projects, they're basically extrusions of graphs. And why would you do that? So later on, when we have a little more time, I'll talk you through one of our models. But what we really want to do is to say, how do you teach differently from, the kindergartner up through the corporate market? How do you get across concepts differently? How do you visualize things differently because you have this ability, this wonderful ability to make things in 3D. And one of our other areas we work in is we have a grant now to develop end-to-end geometry curriculum for blind students. And so we're a long way into that.
Thank you so much, Joan. And now let's jump straight into our first segment, which is focused on students. So 3D printing definitely offers more opportunities for hands-on learning and tactile learning. How can this motivate students? And Shweta, I was wondering if you could start us off, since I know that this is an interest of yours. Oh, I think you're muted.
Hello, can you guys hear me?
Yes.
Okay, perfect. So I would start off from the time we started studying. Like, I went to engineering school at Rutgers, and when I studied, I did not have anything like a 3D printer, in my time. And mathematical concepts or physics, for instance, or, analytical sciences, I would just read books and, numerically solve them. But had I had a tangible example right in front of me, say, why is stress happening at a certain point, and why would a bridge fall at, just the midpoint, or how do the sides behave and things. If I had a prototype with me, my understanding would definitely be better than what I would just learn by solving an equation. And if I would compare that to a kid in elementary school who is just learning from textbooks, compared to the same example when he's learning about gears and he learns about moving them together, and he has a 3D print of a gear right in front of him where he counts the number of gears and calculates gear ratio. How much difference would that make? So it just boils down to the same basic question, the way we educate our kids. And I feel hands-on learning has a better grasp over anybody's mental agility compared to just rhetoric, bookish knowledge. And also along with that, say newer techniques, like these days we have careers to choose from, be it anything with architecture, graphic design, visualization of any kind. If we had a computer which had a simple software and we could do simple tools, like, just browse around the CAD model and see how it looks like from 3 different perspectives, our analyzing abilities, our visualization capabilities would be much better at an earlier age than us coming to a later point in our life and deciding, oh, I want to go to architecture school because I find it fascinating. So I think it will be more logical if things are tangible right from the beginning, and 3D printing is a great tool that fosters hands-on learning. So be it learning at any point, early college, early school, early science, or, be it in the hospital or medical field, I think it definitely gives a better way of understanding, because you learn better when you can hold something in your hand. And it's not just one strata of the society. I would also say, special kids or children or individuals with disabilities. 3D printing definitely gives you a leverage when it comes to learning. And I think that is the future, the way education should be shaped towards. Yeah.
Thank you for sharing that. Joan or Mayra, would you like to add on to that?
Sure. I think I can give you a specific example. This is one of our 3D printed science projects books, and it's how we teach probability, and it's something that you can visualize, and it's hard for people to visualize. So if I have one 6-sided die, and this is the probability of getting a 1 through a 6, that's the same, right? If I have a 6-sided die, you have the same probability of 1 through 6. But if I have 2 dice, there's no way to get a 1 anymore. There's a whole bunch of ways to get 7. 3, 4, and 5, it becomes a bell curve, becomes a normal distribution. And so that's interesting for 6-sided dice, but the model also allows you to look at what happens if you have one 12-sided die, 2 6s, 3 4s, or 6 coins, if you're doing role-playing games, as kids love to do. And so this lets the model, how can I play around with different numbers of dice, different numbers of probability. All our models are open source. So our business model is that we put all our models out open source in a program called OpenSCAD, which is a freely available program that's wonderful for doing mathematical models. And so, you can teach very, very differently. I think our biggest challenge has been that to use 3D printing or open source electronics, which we also use in our teaching, effectively, you have to start over and redo your curriculum end to end. So you can't just kind of graft it on. I mean, you can, but you lose a lot of the power of it. You really have to sort of start over and say, how do I start teaching from 3D printing? And we've come up with calculus curriculum. We've been teaching to gifted 12-year-olds that way. So it's been a lot of fun.
And building on what you just said, how can 3D printing actually be used to help students who do learn differently?
So we've been teaching, we've been developing curriculum for blind students in collaboration with San Francisco State's visually impaired teaching school up there, Ting Su, who is wonderful. People who are blind from birth visualize, interestingly, somewhat similarly to people who aren't, but obviously they need the tactile models. And so, if one thing that's very hard to teach somebody blind is cutting across a cube is a classic problem about how do you cut a cube. Oops, you start off with a cube. How do you cut a cube but you get a hexagon across it? It's a little hard to see here. And it's not, and you could just cut across it, but it's really challenging for them to figure out how to line it up. So one side here is extruded out a little bit, one side is in a little bit, and you can put these together, so that you can really sit here and feel them and learn a lot from them. And we've started bringing along models when we do mathematical talks at conferences, and because we have a blind following, a lot of times people will come to conferences that we're presenting at. We hand out models to pass around during the talk, and everybody loves them. So the core of universal design is that, people who really need it, but universal design means that other people also learn it better as well.
And Mayra or Shweta, would you like to add to that?
Yeah, I don't work with people with some kind of physical difficulty, because it is a little bit difficult to be a dentist with this kind of difficult deficiency. But some students, they have difficulty to understand the geometries, because we have to develop some kind of designs for the restorations and something like this. And it is a specific form. And sometimes they have a difficulty to understand how and why we are doing that thing. So we are trying to use the 3D printing and the 3D technology, the CAD technology, to teach them why the things are how they are now, and they can suggest something different. So they can ask why they are doing these things at the same way during all these years, and they can try something different. And they can use the CAD to design their ideas and print this and test if it's going to work or not. Mm-hmm. So it is an opportunity to develop something that is some idea they have in mind. And everybody, when we were at the university or at the school, we have to believe somebody's teaching us, and not test something really fast. So if somebody tell you something you don't understand, or you don't agree, or you think something different, you can test and you can check if it works or not, or you can simulate something different and expose for someone else. So I think it is a great opportunity for people that have different kind of learning process, because we are always teaching the same, and some people, they have different kind of learning process. So I think it's important for them to have this opportunity.
Thank you.
I believe that kids or individuals with disabilities, it's definitely better if you have something tangible. This is a model of our prototype school that we are planning to build in the next couple of years. And it's just visualization. How are you making the windows and the doors and the right calculations and the geometry? It's just that I cannot see anybody's screen right now. Is that a problem I'm facing? Okay.
I think I'm able to see the screen. Oh.
Okay, well, as long as, So I definitely feel different kind of projects with the kids, especially, with autism. I feel they are very sharp in different areas, be it calculation or mathematical. And this is a great way for them to engage themselves in activities that help them create better learning experiences. It's just that I feel our role here comes in when we can show them the way, what different things they can use to make things. Design, I think, is very vast. From maths to getting to real construction and engineering, everything can be tangibly analyzed, and you can put numbers everywhere easily. Plus, it makes it a fun experience for everyone. I wouldn't feel bored teaching a class if I were to give them tangible experiences myself, because I know this is new, and this would turn some kid today who's learning about numbers into, a civil engineer or a construction person in the future. So I definitely feel this is a great way to educate kids or individuals on.
Definitely, thank you. And moving to our next topic, I was wondering if you guys could share some affordable 3D printers or online resources that could be helpful for people who are beginning to get introduced to 3D printing.
Sure. Do you want us to type it on chat? I mean, we work with a lot of DIY kits because everybody is like, we want to try this next gen tool and toy. So part of the reason is we work with these. Earlier, we used to get these printers, which are DIY units. Some of them are like reality brands to begin with. The only thing is that they need a lot of maintenance. You need to actually put them together. So in schools, especially engineering schools in their first year of school, we get them to build a whole 3D printer project so that they learn hands-on as to what goes into making the printer. One, they learn about the logic of building. Two, they learn about the concept that goes into building. So yes, Ender 3, Prusa is there. Prusa, I would say, is more on the high end. It needs a lot of specifics. Ender 3, Ender 3 Pro, Ultimator, they're like one of the best, most easygoing printers. They work well. It's just that getting a printer is not where the job ends. You have to use the right materials with that. You have to take care of the printer. You have to maintain it. So it's not like a toy you keep in the corner. There's a lot of things that are involved with it because there's a lot of mechanics. And I feel if somebody's taught from scratch how to go about building the printer, how to go about printing at the right set of conditions and temperature requirements and what about the heat at bed and things like that, I think they would have a more holistic approach to running any kind of thing. So Enders are great. I love them. I personally recommend them. I take them everywhere, like our STEM clubs. They are handy to use. It's just that you have to give them a training on what to do and what not to do. Because there's a lot of filament brands that I will never recommend, which are made in China. They have given me a lot of problems. So American manufacturers, actually, ADP Filaments, they are one of our best partners. We work with them. They make good quality filament, which is very comparable to Pusamets. So yeah, I think within US itself, there are great manufacturers who make amazing filaments, as well as they are starting to make a lot of DIY kits together. And probably, I think 2 to 3 years from now, we all would be able to make 3D printed 3D printers by ourselves. So Jellybox was a good printer, Ronaldo. The only thing I had difficulty was consistent running of the printer. Like, it would have very loose ends when you're trying to put the filament in. So I would personally not recommend Jellybox, but Enders I definitely would, because even if the nozzle clogs, you can change it. So it's an easy fix. Prusa is great. I love the quality that comes, but I think part of the reason is the slicing is also important when it comes to the software usage. Overall, Prusa is a great printer, but it's just high maintenance because if you break it once, then it's hard to fix. So I believe that in the beginning, when we're going for a printer, we should go for something which is easy to use, quick fix, and at the same time, which will allow you to learn a lot more doing hands-on things.
And if you think of more resources, feel free to add them to the chat. But I did want to discuss, 3D printing is definitely applicable to many different industries. So how can educational institutions maybe train students in 3D technology based on their career interests? Mayra, I know that you work with undergraduate students in the dental industry, so could you talk on this?
Yeah. What I think now, we have opportunity to transform dentistry. So I will talk specifically about dentistry because it is a market that is growing in 3D printing. And we have a different kind of approach for the students. Most of them, they are always being taught how to be a dentist, how to have an office. And I think from now we will have opportunity to introduce them at the industry as it is done for the engineers, for example. They learn, they are trainees at the industry, they develop something at the industry. So I think there is an opportunity for dental students in this field. As we used to work different kind of printers, we most of the printers we use, they are resin-based. So we have to use different kind of materials. They are biocompatible. And it is important to have this work together with the industry, so we can teach them what we need in our ops, and they will know what kind of difficulty we have and what kind of materials we will need. I will show here something that like this. This is a printed denture, and so we have to have a good surface. It had to fit, and it will have to have a long use in the mouth. So it has to be biocompatible, and all these little pieces to make it work. So we can work with the patients at our office, or we can work developing this technology to make this better and better. So I think it is an opportunity to the companies to introduce the students in their routine and their training programs. And it is not a reality until now, but I think it's going to be in the future.
Definitely.
Yeah, I'd love to add on to that. So the other thing we do as a company is we work a lot with LinkedIn Learning. And so we have, I think, 7 classes now on LinkedIn Learning. And so if people are, in a corporate situation, there are a lot of reasonable cost things out there. LinkedIn Learning, you can subscribe for a month and binge classes until you can't stand it anymore, and do it that way if you want to. But I think a lot of people pick it up because they need to do something at work. So I'm a believer that yes, you can learn all the ins and outs of 3D printers, and I respectfully disagree that Prusa Slicer is hard to use. It's if you use the defaults, it's perfectly fine. We use Cura and Prusa Slicer interchangeably. And once you get past doing very, very simple stuff, the reality is that it's like cooking, right? I mean, you wouldn't expect to have a button on your oven that said bake. And if it did, well, mine does, but you still have to set the temperature and stuff, right? And so I think you have to set expectations reasonably, that you're going to need to learn some stuff to do this. And so what we've seen at most schools is that most schools have a kid or a teacher who really gets into it, and then they manage the equipment. And that's just reality. I mean, that's true for the copier at a school, right? So there was some things in the chat here asking about Tinkercad. Tinkercad does work on Chromebooks, but it's a little limited for mathematics. And the OpenSCAD only works on desktop machines or laptop machines.
And Joan, I did want to follow up on something that you had mentioned earlier, which was that we should be teaching people why to use 3D printing. So do you think you could elaborate on that a little bit?
Well, I think when we started out this company 6 years ago now, everybody wanted to learn 3D printing per se, right? It was cool and and stuff, right? And it was still a little hard to use most things. But about a year in, everybody started getting disillusioned, the famous trough of disillusionment, right? And, why am I doing this? And I think, so we started developing our curriculum. So for instance, this is an OpenSCAD model. That's about a page of OpenSCAD, which is also a good way to teach coding, by the way. OpenSCAD is all text and all code and can be used even by blind students. So this is a botanical model that encodes some basic rules of botany. And so you can take apart the rules of botany and you can start to invent plants. So you can play around. This happens to be a camellia, but you can play around with what kind of weird and wacky plants can I invent? And then you can go backwards and say, what kind of plant might evolve like that? How do you predict what kind of plant might evolve? And you can do some very interesting learning that way. This is the Earth-Moon gravity well. So if you wanted to climb out of Earth's gravity, you would have to come all the way down here someplace. If you want to get out of the moon's gravity, you're up here. This is some very basic math that goes back to Newton and Kepler. And when we first printed this out, I thought it was an error because I had a mental model of how deep this should be, and it's only, and I didn't realize it was this small. So I've learned all this stuff, back in college, but when you actually make a 3D model and you start to mess with it and you start to look at it, you find a lot of really interesting subtlety that you didn't have before. And so I think the power of this is that when you actually have to make a 3D model, you're not just taking and redrawing the same textbook image that everybody has used for 50 years and they redraw it so they don't get sued, right? You're really, really thinking about how do I take a science or math concept in 3D? And we started out doing that with the, with some individual projects. And then we said, okay, now we really need to look at doing end-to-end subjects. And we've gotten some sponsorship for that. We're always looking for more sponsorship. If anybody's out there. We have this end-to-end geometry now, which will be out open source in the summer. And there will also be a book from Maker Media and our books are all very affordable, especially in ebook form. So hopefully that's helpful.
That's great. And moving to the company side, each of you has founded a company that provides educational resources to students that are working with 3D printing. So in your opinion, what are the benefits and the impact that companies like yours can have on 3D education?
I can start if you want. Well, I think for a long time we were pretty much alone in the space. I think we're still alone in the math and science curriculum space, we work with large publishers. We're only 2 people, basically a creative partnership. My partner was one of the early rep wrappers, designing 3D printers, and we have 2 Frankenstein machines that he keeps adding to keep them modern. So we don't worry about buying our own machines, but I think the impact the 2 of us have had is to get into the why, and the how will come. People will learn the how if they have the why. And we find that kids will learn to do 3D printing very effectively if we have a system that we use with a lot of the places where we teach directly, where we have kids have kind of a public shaming, if you will, that if kids submit something to be printed out at their school, we review them first and bounce it publicly to be fixed if it won't print. And most kids will only be bounced once. And that becomes mine was approved first time through kind of thing, right? And Tinkercad, somebody mentioned it's really easy to do that because the kids can share their screen. We're teaching online at a school for gifted kids right now. But the general thing is, I think we all need to be clearer on why. We have a weekly series on LinkedIn Learning that we kind of have about 50% tips and tricks on how and about 50% applications and why. And people are very interested in both of those. And I think the industry has been a lot about how without enough why. And so that's why we're trying to be in the why space.
Okay. Yeah, I feel we founded a company with the whole perspective that we could be a bridge between the companies that have so many 3D printers and how we can get them in schools to learn it in the right way. That's how, the whole rep wrap culture started with MakerBot launching the initial printers. So we were also prototyping our own DLP 3D printer, which was supposed to do like multi-layer stuff. And we put like a year in just like trying to develop micro and macro resolution into it. But when we did our market survey, we were funded by NSFI Corps. We realized that, when you are trying to approach a community, be it people, designers, artists, women entrepreneurs, or whoever, the first thing, 3D printing 2 years ago was a niche. It's still growing, I feel, but not everybody knows about it. So it's important to know how beneficial it can be as a tool before we go about, teaching or training concepts. So that's where we came in, that we thought that educating communities was more important than just going about fabricating or making our own machines. And so we started with local community groups, and then we went around to schools, and now we are in New Jersey trying to work with universities and college grads with their curriculum and training programs. So I would say having your own company is not limited to just training. If you have an application in mind, say you want to be a planter designer, Okay, let me give you an instance. The other day, since our startup also focuses on environmental friendly solutions and we want to save the environment, ELA is a great way. This you can customize really well using 3D printing, and I think that is the power of 3D printing. Anything custom can be made, and then you can mass produce it if you have 20 to 40 printers. So if you want to be an entrepreneur and you are looking at making something specific to certain field, it could be home decor or it could be into jewelry or molding. I think it's a great way because if you definitely need to know how to design and designing in a space that you are confident in. So, it could be jewelry making, it could be specific gifts. It just depends on what you're looking to build yourself in. And I think 3D printing gives you the right kind of training, adaptive to your course or style, that can make that possible. So, to a plant designer, you can make so many different shapes and customizations out of it. And then you have a business out there because everybody has plants, and, you just have to think it in a way that suits you the best. And then design is there to solve all the problems. So I definitely, go for it, Sanjana.
I was just going to ask, Mayra, I know that you have a university perspective on this, so would you be able to talk about some of the benefits at a university level?
What I'm trying to do when I founded my company was to accelerate the adoption of the 3D printing at university. So what I feel nowadays, what I hear from people nowadays is that they don't know how to use. It is a little bit scary. So what I'm trying to do is to bring the teachers, the mentors, to understand this better, so they can introduce this during all the time at the university. Because I believe that when you are living the 3D printing philosophy, you are going to innovate and creating something else. And it is not about learning what kind of button I'm going to press, or how kind of resin I'm going to use. It is about thinking about 3D printing and the method, and how can I create something new and innovate and do something specific for some patient or for some technique. And for people to be confident with this, they have to live this. So the teachers nowadays, they don't feel comfortable using all these new technologies. And because of this, this is my goal, this is my proposal, to bring confidence for them to use this, to understand where they can use their expertise together with the technology and create something new, and it is going to be easy for them to go through this technology. So I think university in healthcare and dentistry, they are a little bit far away from the technology. We are we are user of cell phones or computers, but we are not in the creating the technology. So it is a little bit scary when you are going to go through these new technologies, and it is important to be easy. As for kids nowadays, they're born and they have a cell phone and they know how to use, even if they don't read. So it has to be the same for the universities and the teachers and the students.
That. And to wrap up this segment, I did want to ask, what are some of the greatest challenges for companies that are looking to support and provide 3D printing resources for students?
Well, I think we found the biggest problem is teacher fear, especially online right now. Although ironically, we've had some really good luck with getting people started, and some schools are basically running service bureaus where they're sending prints home to kids when they've designed something. So that I think obviously in the pandemic, there are many challenges for teachers, but I think some schools have very effectively kind of turned themselves into service bureaus. But the main thing is teacher fear, and that's one reason we've gone over to saying, look, as a motivation. Look, you can make something really different and really powerful, and you can have kids really invent some stuff. If you learn just how to make brownies, we just keep on the cooking analogy, just how to make brownies. Don't try to make a wedding cake out of the box, which everybody tries to do. And all our models are designed to print without support and on a crappy printer that is out of school and has had people jumping up and down on it and all that stuff. So, I think it starts simple. Think through making things simple for your user, and and then things will follow from that. It's good content.
Shweta, would you like to add to that?
I think companies they have to understand where they can improve these methods, and how can they do something similar like I'm doing, and how make things easier to be adopted. So that's the opportunity for them to grow in this industry in 3D printing. So as much as easier to use, and it is comprehensive, the method, and when they support the research or the early adopters, I think it's an opportunity to be close to the new ideas, to develop something new, and to have this accessibility for all the people. So I think this is a good opportunity for companies.
And Shweta, did you want to add something?
No, I think, companies can assist in a lot of different ways. Like, I still feel education is lagging. I mean, we're not yet there with the whole hands-on thing and, all the schools adopting to it, partly because we are not funded or supported by companies that well. Like, say, carbon, for instance, if we could manufacture things fast, be it resins in, the dental space or in the jewelry space, for instance, if they can help us with their resources and help us teach better, I think that would be one way companies can be a part of our program and culture. But I think it would be a great way of collaboration for their end as well, because they are exposing the kids and the individual students to, nicer and faster and better machines. And at the same time, they're using our concepts and education skill set in order to evaluate things at a better way. And does that answer that?
Definitely. And to wrap up our discussion, since we're almost out of time, I did have one final question that I thought each of you could briefly touch upon. How do you envision that 3D education will progress from here?
I think 3D education has already progressed from what I saw it be like 5 years back. Like right now, I see 3D everywhere in what I imagine things to be like. From basics. Okay, let me show you. This is one of my favorites. Do not look at the nose, I broke it. But you will recognize this genius. So you kind of do know how we can make life a better experience if we imagine things in the whole three-dimensional space. And it could be anything, like, something simple. You sit at home. A 3D printer is like a daily microwave. That's how I see it. If you guys have seen Star Trek, you must have noticed that there was a replicator in it in which something magically used to appear. So that's how I see 3D in the future as, you want something, you get it. You don't have to go anywhere. You don't have to go to a retail store. You can just make it, sit at home. So, and with that approach in mind, we can apply it to all different applications where we are currently seeing the trend rise. So from home decor to medical, to architecture, to education, anything for that matter. Learning is better, tangibility is better, and then you can be an entrepreneur. I mean, that's the end goal. You are making your own things and it's your own brand, and it could be anything, for instance. So there is just a growth curve. I don't see why we do not see 3D anywhere. It's just that I feel we have to use it in a more adaptive way. To me, something which is very close to my heart is my goal for women empowerment. And I definitely want to see that grow using its application and benefit in the cottage industry. So, coming up with custom fashionable handbags, for instance, you design it, you carve it, and then you can make it. Plus, it turns out to be something which is very environmental friendly. So it's just that you need to find your niche, and then 3D printing will be there for you.
That's a great point. And Joan or Mayra, do you want to touch on this really quickly? I think we have about a minute left.
So I think I've largely covered this before, but I think it's been interesting that the assistive tech and the students who perhaps have a disability have kind of been a first market for this stuff, and it's kind of like a classic case of universal design, that it's sort of merging out into everyone else from that, and we hope we'll be able to help keep enabling that. And I put my email in the chat if anybody wants to follow up.
Thank you so much. And thanks everyone for joining our discussion today, and a very special thanks to all of our panelists, and I hope you enjoy the rest of the conference.
Thank you.